Is it okay now? Yes. Thank you. Hello, everyone. So this presentation is about the virtual disk performance benchmark. I will run on a cluster we have set up for that. So what is it exactly? What we will have behind, it's a 0 dB server, which will do the backend to store the data of the VDisk. This will run under a QEMU for like a virtual machine running with KVM, and the disk will be attached as just a virtual disk, except that the database is the 0 dB behind. And yes, we have put up some hardware to do the cluster test. What's the test objective, of course? Well, we will run a lot of VM, a lot. I don't know what exactly is a lot, but right now it will be 16 VM per machine. We can go up. I made the test with more, but too slow if we it's gonna take too long time if we do more than 16. We will check the throughput for on the host and on the VMs. Of course, the IOPS too. We will see if the 0 dB itself just slow down the complete environment or just or if it's still okay. The host performance. Actually, I made some mistake during my test before, and I could see that even by running more VM than expected, it was slower, but it was still completely stable. So we will see if the pressure when running a lot of concurrent settings will still keep it running. And of course, we will see if it goes fast or not. The cluster we set up for this is 10 nodes. 10 nodes using an Xeon CPU, and mostly what is important for us is we have 4 SSD on each node, 2 Samsung and 2 Intel. And we will see during the test that we will clearly see a difference between the Samsung and the Intel one, mostly because the size is not the same, so the Samsung is definitely faster. How will the architectures works? On the ZeroOS, we have, as I said, 4 SSD, 1 0 dB per SSD, and only this, nothing more, nothing less. And we will attach 4 VM per 0 dB, so they will all concurrently reach the same SSD underneath, and they will all concurrently talk with the 0 dB itself. And on the overall system, we will have 16 virtual machines per host, which means 160 virtual machines in total. And for the benchmark, I will run FIO. I will do 3 tests, a complete basic read test, a complete basic write test, and then the most important one is the random read-write test, and everything is using 4 kilobyte blocks, not more. So it's the basic test, the slowest test that you can do, actually. And the configuration, if that interests you, is this one. There are more arguments, but basically that's all you need to know. It's a 4 GB file that we write indirect, so we bypass the kernel cache. So we directly, from the QEMU, we directly talk to the 0 dB. We don't use a virtual machine, the kernel of the virtual machine as cache. And yeah, the test is read-write and random read-write. So let's go for a short time. I will show you at first. Here it's a summary of the 10 nodes running. So we have 10 nodes. Each of them have 56 cores running. All the VM is already up and running, the load average of the system. And we will see here how the disk throughput for read and write and some IOPS. But that's just for the host. This is really, we will directly here, what we will see is directly what we do on the SSD directly. What is more important and what is more interesting is this one. We have the 160 VM displayed here. We will monitor all of them, each one, and everything will be updated mostly in real time. So as soon as we will start the test, we will see a lot of information here, but the most important information are on the top, because here we have the overall IOPS for this clustering of VM. And this is, of course, what we need to show. I actually have a lot of data and my laptop is not liking it really. And Zoom is using a lot of power. Okay, let's hope it will work fine. So what I will do is just run the 3 FIO tests. It will start by the read one and then by the write one. And then for the random read write, if needed, I can do them separately. It's completely lagging. I hope it's okay. So I will just run, the benchmark will just run the FIO on the 160 machine. And if you want more detail about the code or not all of this, we can still discuss it later. Let's start running the performance test. Now is the read test, which is running on all this 160 machine. So you see each them separately that we do only read for now. And this is the overall system that we just compute. It's just the sum of all the machines at the end. And we can already see some difference between some machine like this one and some other one, because we will maybe see already which one is the Samsung and which one is the Intel. Yeah, if you have any question during the test, just shout out. Okay, we see that some node is already doing the write test, like this for the first one. And we can see here that it's switching to the write test. And as soon as the write test,
how many virtual machines?
What?
How many virtual machines?
Here, 160.
160 virtual machines, and on how many physical nodes?
10.
Wow, that's very fast. So it's about.
That's the, okay, you can see here, for example, that's the physical node if you want. So we can see the throughput directly writing on the SSD. This is really what we are writing now on the SSD. There are 4 SSD, of course. And yes, we are writing like more than 1 gigabit per second, 1 gigabyte per second on some SSDs. Yeah. This is really what you have on the SSD itself, and this is the aggregated value that you have out of the QEMU. And we are still on the write test. Some of them already start the random read write.
Yeah. Oh, that's cool.
Yeah, it's lagging. We can already see that from the read write that the balancing between the read and write is really well split. And even we can see that all the VM running have a constant bandwidth. So there are no flushing time or thing like this and going down to 0 and doing some yo-yo. And here we can clearly see the difference between the Samsung and the Intel.
Yep.
So slowly the tests are going to stop, like this one is done. So the IOPS, the overall IOPS of course will go down because some machine is done. You can check some read write and some done text. And again on the host, we're still busy. And yeah, what we can see is that I didn't show it during the test, but the RAM didn't go up since we ran the test, and the overall CPU usage is still less than the half of the system at the end. the good things about the 0DB itself is that you are for sure that each instance will never use more than one core because it's single-threaded. So for sure, you are sure that the 0DB itself will not take the system down. Or at least it can take one core down, but not all the system down. And yeah, of course, now it's only the Intel remaining. Not for this. And now, except waiting that all the remaining machine is done, there's nothing more to show about the performance. So I will read again the demo to add the recording value to put the value that we had on the slide, to put it on the last slide here. And if you want more information, you can just check the 0DB repository for the VDisk behind, or ask me something. And yeah, if you have any question, of course, just short. No question?
I think there are questions in the chat.
I don't see them.
How many disks per VM?
The VM are running Ubuntu started from an FList. So the virtual disk attached to the VM are just used for the fire test. The root itself is just the FList behind. And disk per VM, actually we just use one disk per VM, but all the VM have 4 disks attached, but we only write to one of them. But for 4 VM, we will reach the same disk behind.
Very cool.
More than cool. That's crazy. Great, Maxime.
Very nice interface in which you show the numbers as well.
This is a dashboard. I can give some link about it.
Well done, Maxime. It's really cool.
Thanks.
Yeah, I was thinking maybe we could also attach the code that you use to deploy stuff a bit. I think that could be a nice script to show how to use the SAL to deploy stuff also. Maybe attach it to the slide or something.
Yeah, I will do a repository special for that, or not a repository, but somewhere in a repository specially for that. Yeah, because next week we will allow people to run the test on their own environment, so they will have the code anyway.
Sounds good.
And if it's done, that's it.
Yep. Okay. Thank you, Maxime.